Intro to Decimals. In this video we will talk about decimals, place value, and arithmetic with decimals. So let me say at the outset, if this is something relatively easy for you, if you're very comfortable already with adding, subtracting, multiplying, dividing decimals, then you probably don't need to watch this video. You might just want to skip through briefly to make sure that everything is reviewed, but don't spend time watching this whole video if you already know this inside out. This video is designed for people who are a little shaky with decimals and want a thorough review of the topic. So let's begin. First, think about positive integers, just ordinary positive integers. If we have the number 256, what that means is we have 2 hundreds, 5 tens, and 6 ones. Those are the place values. So we could write this number in the form 256 equals 2 times 100 plus 5 times 10 plus 6 times 1. That's expanding it in terms of its place values. Notice that as we move a digit to the left, the place value is multiplied by 10, and as we move a digit to the right, the place value is divided by 10. So for example, look at that 8 in the middle. That 8 is in the thousandth place. If we move to the left one step to the 7 is in the 10,000th place. So when we move from the 8 to the 7, the place value gets multiplied by 10. Similarly, if we move to the right, from the 8 to the 3, the 8 is in the thousandth place, the 3 is in the hundredths place, and so the place value gets divided by 10. Decimals simply extend this same pattern to the right of the decimal point. For example, the number 39.0625, what does that mean? Well, first of all, the 3 is in the tens place. We have a 9 in the ones place. The 0 is in the tenths place. The 6 is in the hundredths place. The 2 is in the thousandth place. And the 5 is in the 10,000th place. We could write this number as follows. We could write it as 3 times 10 plus 9 times 1 plus 0 times 1/10 plus 6 times 100th plus 2 times 1,000th plus 5 times 1/10,000th. So this is the expanded form in terms of place value. The decimal places to the right of the decimal point represent negative powers of 10. So 0.1 is 1/10, that's 10 to the negative 1. 0.01 is 100th, 10 to the negative 2. 0.001 is 10 to the negative 3. 0.0001 is 10 to the negative 4, and so forth. You could extend this pattern. What can be a little confusing about this? There are a few things that are a little confusing. First of all, notice the 0 to the left of the decimal point. That's purely decorative. I put that in for clarity. That has no mathematical meaning. All that matters here are the numbers to the right of the decimal point. Now, some people get confused because how many zeros should these things have? Well, if we look at 100, for example, 100, 10 to the positive 2, that's 1 followed by 2 zeros. That's very clear. People recognize 100. So then when we go to 100th, notice that that's something that only has 1 zero. It's 0.01. It only has 1 zero, and that really confuses people. But notice that 0.01, that's 2 decimal places. And this is very important. If we look at a positive power of 10 and count the number of zeros, that number of zeros will be the same as the number of decimal places in the corresponding negative power of 10. So again, say the number 10,000. The number 10,000 has 4 zeros. Well, the number 1/10,000th, 10 to the negative 4, that has 4 decimal places, 4 places to the right of the decimal point. Also notice that the additional zeros to the right of any non-zero digits are meaningless. They make absolutely no difference. So for example, if I write 3.75, if I tack on extra zeros to the right, those are completely meaningless. They mean absolutely nothing. Now you may have this dim memory from science class that there was something called significant figures, and sometimes these zeros mattered and sometimes they didn't. We're not going to worry about that. Significant figures are not on the test. The way that they use numbers in science is not the way that they're used on the test. So on the test, these zeros are completely meaningless. Now we can take a look at arithmetic with decimals. Adding and subtracting decimals is quite straightforward. We simply line up the decimal points and add or subtract vertically. So suppose we have to add these two decimals. We're going to line them up vertically. So the decimal places are lined up. Once they're lined up, then we just add. Similarly, if we have to subtract these two numbers, we're going to line them up. The decimal places are lined up together. Now that they're lined up, we're simply going to subtract. And that's all there is to adding and subtracting decimals. For multiplication, step 1 is to count the number of digits to the right of the decimal point. So suppose we're going to multiply these two numbers. For each one, we have to count the number of digits. The first factor has 2 decimal places, and the second one has 3 decimal places. Now we add those. 2 plus 3 is 5. The product will have 5 decimal places. So now we know how many decimal places the product will have, even before we do the multiplication. Now we're just going to ignore the decimal points entirely and find the product as if they were 2 positive integers. So suppose we just had the 2 positive integers, 625 times 48. What is this product? Well, how do we find this without a calculator? Turns out there's an amazing trick that we'll talk about in a later video. This is called the doubling and halving trick. Turns out when you're multiplying two numbers, of course, one thing that's always allowed, you could multiply one of them by 2 and divide the other by 2. That's one thing that's always allowed. It turns out that it's very advantageous to do this if one of the numbers is even and the other number is a multiple of 5. Turns out that it's very advantageous to do this. So what I'm going to do, I'm going to divide 48 by 2. That's going to become 24. I'm going to multiply 625 by 2. 625 times 2 is 1250. So I change this to 1250 times 24. That has a 50 in it, so I'm going to multiply that by 2 again. So divide 24 by 2, I get 12. Double 1250, I get 2500. Well, that also has a 500 in it, so it makes sense to do this again. I'm going to double 2500 and halve 12. Half of 12 is 6, and 2500 doubled is 5000. Well, now I've got it into a form where it's very easy to multiply in my head. 5000 times 6, that's 30,000. So this is a very handy trick to keep in mind. Now we know we need 5 decimal places. We found that out from the original problem. So we put the 5 rightmost decimals of this product to the right of the decimal. And notice that this product only has 5 decimal places. It only has 5 places, so all of them are going to get put to the right of the decimal point. So when we multiply 6.25 times 0.048, we get point, and then we write 3, and then all the zeros. Well, of course, all those zeros don't matter. We can just write this as 0.3, 3/10. Notice that to find a power, that's a special case of multiplying. So, for example, suppose we have to do 0.03, this is 3/100ths cubed. How do we do this? Well, of course, this is 0.03 times 0.03 times 0.03. Notice what we have here, that's 2 plus 2 plus 2, 6 decimal places. The product will have 6 places to the right of the decimal point. So we know that even before we multiply. Now just consider the number itself. 3 cubed is 27, so that last 7 must land 6 places to the right of the decimal point. It must land in the 1/1,000,000th place. So 0.03 cubed is 0.00027. That 7 is 6 places to the right of the decimal point, and this is 27 millionths. Now division of decimals. To start, simply move the decimals of both numbers 1 place to the right and continue until the denominator, the divisor, is a whole number. When we move a decimal 1 place to the right, say 2.45 to 24.5, we are multiplying the number by 10. Since we multiply both the numerator and the denominator by 10, the value of the quotient remains unchanged. Essentially what we're doing is we're multiplying by 10 over 10, which is 1. So for example, suppose we start with this. Well, we can start sliding that decimal point to the right. Slide it to the right once, slide it to the right again. At this point, the numerator is now an integer, but it's really the denominator that matters, so we have to keep sliding to the right. What this does is adds zeros at the end of the number in the numerator, and finally we get that number in the denominator down to an integer. Now we have 5,600 divided by 7. Well, that's easy to do. That's just 800. So now, let's look at another example. Suppose we're dividing these two decimals. Again, start sliding to the right. Sliding to the right 1 point. Well, now notice we could keep on sliding to the right, but notice 0.25, that's a quarter. So notice that a very easy way to cancel that would just be to multiply the numerator and the denominator by 4. And if we multiply by 4, in the denominator, quarter times 4, that's just 1, so we multiply the numerator by 4, and of course we get something over 1, so it just equals 0.0052. So 52 ten-thousandths. In summary, we talked about place values and decimals, and we talked about how to subtract, add and subtract, multiply and divide decimal numbers. Rounding. To begin, we will discuss a couple ideas that may initially not seem to be related to the idea of rounding, but they will be important in that discussion. We need to consider the nature of decimals on the number line. So the first question, how many numbers are between 3 and 4? Think about this for a minute. On the number line, how many numbers are between 3 and 4? Of course, there are no integers between 3 and 4, but that's not the question. I'm not asking about integers. I'm asking about numbers in general. There are decimals between 3 and 4. How many of them? Well, of course, the answer is infinity. There's an infinite number of decimals between any two integers. So that's mind-blowing fact number 1. Second question, how many numbers are between 3.99 and 4? Well, again, the answer is infinity. And then the next question, now we're getting a bit ridiculous here, how many numbers are between 3 and a whole bunch of 9s after it? Looks like there are 20 9s after it. Between that number and 4. How many decimals are in that tiny infinitesimal little gap? Well, turns out there's still infinity. This is a really deep idea. Between any two numbers on the number line, no matter how close those two numbers are, there lies an infinity of points between them. That is a very deep idea about the nature of decimals and the nature of the number line. This fact, this purple fact, will not be tested directly on the GRE, but knowing this will give you important perspective in the discussion of rounding. Rounding. So now we can talk about rounding. Let's start very easy. Suppose we are rounding to the nearest integer, and suppose there is only one digit to the right of the decimal point. The rule is very easy. If the number in the tenths place is 0 to 4, then we round down. If the number in the tenths place is 5 through 9, then we round up. Very straightforward. So here, we'll select those, first of all, that are in the first category, the 0 through 4 category. Those all get rounded down. Now the other ones are in the 5 through 9 category. They all have digits in the tenths place that are 5 through 9. And of course, those ones get rounded up. So far, so good. Now we add a twist. We are still rounding to the nearest integer, but now we could have any number of decimals to the right of the decimal point. Here's the tricky part. We look only at the number in the tenths place and no other number. If the number in the tenths place is 0 to 4, we round down. The number in the tenths place is 5 through 9, we round up. The subsequent decimals, anything beyond the tenths place, is absolutely irrelevant. Well, here's what I mean by that. So, of course, most people are pretty clear in the fact that numbers like 7.12 or 7.384, those get rounded down. And, of course, 7.96 or 7.532, those get rounded up to 8. Most people get that. But where it gets tricky is when we have a 4 in the tenths place with more digits behind it. So, for example, 7.45, that has a 4 in the tens place, so that gets rounded down to 7. 7.49 gets rounded down to 7. 7.49999 gets rounded down to 7. Now this starts to confuse people because people look at that and they say, well, gee, 7.4999, that's essentially 7.5. But we have to be very careful here. How many decimals separate 7.49999 from 7.5? Well, as we just talked about, there's an infinity of decimals separating them. And because there's an infinity of difference, one gets rounded down, but 7.5 would get rounded up. As you might infer, a very common mistake, and here's the mistake I'm trying to target, the mistake of double rounding. People look at something like 6.48, and we have to round to the nearest integer, and so they do this. They say, oh, well, first of all, let's look at that 8. That 8 gets rounded up, so the 4 gets rounded up to 5, and now the 5 has to round up the 6 to 7. And so what we've done is we've done rounding in 2 stages here. This is 100% incorrect. This is not what you're supposed to do. Instead, you have to look at that 4. The 8 is irrelevant. Look at the 4. The 4 gets rounded down, and so 6.48 gets rounded down to 6. Very important to avoid double rounding, which is a very common mistake. Now we are ready to generalize. The GRE could ask you to round to any decimal place, the nearest hundreds, the nearest thousandths, etc. When you're asked to round to a place, look only at the digit in the next place to the right, the next smallest place. The same rule as above, 0 through 4 rounded down, 5 through 9 rounded up. For example, if we're going to round this number to the nearest thousand, well, we look at the number in the next place, the hundredths place. That number is a 5, so we're going to round up. And so that means it gets rounded up to 66,000. That's the nearest thousand. So here are some practice ones, and I'd suggest pause the video here and practice these on your own. And here are the answers. In this video, we discussed the rules of rounding and covered the mistake of double rounding. In this lesson, we will talk about ways to multiply and divide by 10 quickly, and also to multiply and divide by powers of 10. Now, for some people, everything in this video is going to be review. You don't have to watch the video if that's the case. But if you're at all rusty with these skills, these are really important skills to know for the test. The first idea is that when a multiple of 10 greater than 1 is written in standard form, the number of zeros after the 1 is equal to the factors of 10 in this multiple. So for example, 10,000, that has 4 zeros, so that's 10 to the 4th, or 4 factors of 10. 1 million has 6 zeros, so that's 10 to the 6th, or 6 factors of 10. For powers of 10 less than 1, it gets a little trickier. The number of factors of 10 in the denominator equals the number of places to the right of the decimal point. So for these, we're no longer counting number of zeros, we're counting places to the right of the decimal point. So for example, 0.01, that is 1/100th. That has 2 decimal places to the right of the decimal point, so that's 10 to the negative 2, or 1 over 10 times 10. 0.0001, that is 1/10,000th. That has 4 decimal places, so that's 10 to the negative 4th, or 1 over 4 factors of 10. Of course, in any number, each place value is 10 times more than the one to the right and 10 times less than the one to the left. This is a huge idea. This is a very important idea. It actually underlies everything in this video. This leads to a very quick trick when multiplying or dividing a number by some power of 10. First of all, when we multiply any number by 10, just plain, ordinary, regular 10, we move the decimal point 1 place to the right. So 24 times 10. That decimal place right now is next to the 4. It moves one place to the right, so we have to stick in a place holding 0. One way to think about this, at least for numbers bigger than 1, is when we multiply by 10, is just like adding a 0 on the end. 2.53 times 10. Well, for this, we can't just use the stick on a 0 anymore. We have to remember multiplying by 10 means move the decimal place one place to the right. So it starts out between the 2 and the 5. It winds up between the 5 and the 3. So we get 25.3. 6,400 times 10. We move the decimal point one place to the right. We get a place holding 0. Again, it's like adding a 0 to the end. And 0.00045. That would be 45 hundred-thousandths. That has 3 place holding zeros. When I multiply by 10, the decimal point moves one place to the right, and so I wind up with 2 place holding zeros. When we divide any number by 10, or multiply by 0.1, we move the decimal point one place to the left. So now 24 divided by 10, the decimal point next to 4 moves one place to the left, and it winds up between the 2 and the 4, 2.4. 0.02 divided by 10, the decimal point moves one place to the left. I wind up with 2 place holding zeros, 0.002, 2 thousandths. 39.85 times 0.1, the decimal point moves one place to the left. It starts out between the 9 and the 8. It winds up between the 3 and the 9, and we get 3.985. Finally, 0.00072, that is 72 hundred-thousandths. That has 3 place holding zeros. When I multiply by 0.1, we move the decimal point one place to the left. We wind up with 4 place holding zeros, 0.00072. When we multiply any number by any positive power of 10, we move the decimal point a number of spaces to the right equal to the power, that is, equal to the number of factors of 10. So if I multiply 350 times 100, 100 of course is 2 factors of 10, is 10 to the 2. That means the decimal point moves 2 places to the right, which has the effect of adding on 2 more zeros at the end. Again, that's a trick you can use if the number is bigger than 1. 0.01728 times 1,000. Of course, 1,000 is 10 to the 3rd. There are 3 factors of 10, so multiplying by 1,000 will move the decimal place 3 places to the right. It will wind up between the 7 and the 2, 17.28. 8.3 times 10 to the 6. This, of course, is scientific notation. We're going to move the decimal point 6 places to the right. The first place, it will be next to the 3, and then the next 5 places will need 5 place holding zeros. And we get 8,300,000. When we divide any number by any positive power of 10, or multiply by a negative power of 10, we move the decimal point a number of spaces to the left equal to the absolute value of the power, that is, equal to the number of factors of 10. So if I divide by 100, again 100 is 10 to the 2, so there are 2 factors of 10. When I divide by 100, that moves the decimal point 2 places to the left. It starts out next to the 5. It winds up between the 2 and the 3. 12.35. 0.064 times 10 to the negative 2. I move the decimal point 2 places to the left. I start out with 1 place holding 0, and I'll wind up with 3 place holding zeros. 0.00064. 37.5 divided by 10,000. Well, now I'm going to have to move the decimal point 4 places to the left, because there are 4 factors of 10 there. So the first 2 places, it winds up next to the 3, and then I have to move it 2 more places, which means I'll need 2 place holding zeros to the right of the decimal point. 0.00375. 64,000 times 0.0001, that is times 1/10,000th. That has 4 factors of 10 also, because that is 4 decimal places. This means that the decimal point has to move 4 places to the left. It starts out next to that last 0. It winds up between the 6 and the 4. 5.4 times 10 to the negative 5th. This again is scientific notation. It starts out between the 5 and the 4. It moves 5 places to the left, so we wind up with 4 placeholding zeros. 20.25 divided by 1,000,000 divided by 10 to the 6. This will move 6 places to the left, so the first 2 places get it in front of that first 2, and then it has to move 4 more places beyond that. And so we get 4 placeholding zeros to the right of the decimal point. Notice that dividing by a negative power of 10, a number smaller than 1, has the same effect of making the product bigger. It is equivalent to multiplying by a positive power of 10. So if I divide by 0.01, divide by a hundredth, that's the same as multiplying by 100. And then I just follow the ordinary rule. If I divide by 10 to the negative 4th, that's the same as multiplying by 10 to the positive 4th. And I follow the ordinary rule. One common mistake in these problems is people sometimes get confused on which way to move the decimal point. Always think about whether this multiplication or division will make the number bigger or smaller. Make sure that your answer is bigger or smaller as it should be. One thing that can be very helpful for building intuition on this, if this is something unfamiliar to you, just sit down with a calculator, type in a number, and then multiply it by some power of 10, or divide it by some power of 10, and see if you can predict where the decimal place will wind up before you hit enter. Very good to practice this with a calculator to help you build intuition, and eventually your predictions will get so good that you wouldn't need to do it on the calculator at all. In this video, we learned how to multiply or divide numbers by powers of 10 simply by sliding the decimal point one way or the other.